Now let's take a look at the reliability of a measurement. We have two options that we can look at when we're talking about reliability. That is precision and accuracy. Accuracy is how close the measured value is to the actual value. The closer to the actual value you are, the more accurate your measurement is. Precision, on the other hand, looks at how close a series of measurements are to one another and if they are reproducible. The closer each measurement is to itself, the better the precision of the measurement. Let's take a look at some student data when students were asked to measure a 10-gram mass on a balance. We have three sets of data. Student A had an average mass of 10.12 grams. Student B had an average mass of 9.79 grams, and student C had 10.01 grams as an average mass. Well, we need to take a closer look at their data to determine who is both accurate and precise. If we look at student 1, we see that their average is 10.12 grams, so that's not accurate because that is not close to the true value indicated by the red line. We can also see that this student's data is very imprecise. The points are all over the field. Okay, we have 10.47 grams, 10.32 grams, 9.77 grams, and 9.93 grams. These are all broad, like a buckshot type approach. If we look at student B's data, their average was 9.79, but it should have been 10. So their accuracy is off. But if we look at their precision, all of their values are relatively close together. 9.79 to 9.83 grams is not that much of a difference. So that student has a very precise measurement, but it's not accurate. We can also get accuracy and precision if we look at student C. In this case, their average is 10.01 grams, which is almost perfect to the 10.00 grams that we're supposed to have. And they're very precise. Their values are only different by 0.03 grams in mass. So they're very close together. So we can use our measurements to determine how precise they are to one another and how accurate they are to an actual value to give us a better understanding of what we've just measured. One of the other things that we're going to deal with reliability of our data is look at prefix multipliers. If you take a look at this table that's shown, you'll see that we have a bunch of different multipliers that we use to convert our standard units. The multipliers can change the value of the unit by the powers of 10, and if we start at the beginning, we start with mega, which has a capital M as a symbol, and it means it's the base unit times 10 to the 6th. Kilo, which we've seen before with the kilogram, has the symbol K and multiplies the base unit by 10 to the 3. Deci, which is a small d, multiplies their base unit by 10 to the minus 1 or divides by a power of 10. Okay, so on and so forth does this values work. So what I want you to do is make sure that you review and memorize this table that's also included in the packet that I gave out on the first day of class, so that way you can use these prefix multipliers when we start talking about unit conversions next week. But just so that we have a good understanding of using a prefix multiplier, let's look at 1.25 centimeters. If we look at the previous table, we can see that 1 centimeter equals 10 to the negative 2 meters, which means that 1.25 centimeters is going to be equal to 1.25 times 10 to the negative 2 meters, or 0.0125 meters. You're going to need to get very comfortable with using the prefix multipliers in the conversions that we do, and you have to memorize these before the first exam. In the next video, we're going to talk about significant figures, and that's going to help us